Evening all, how are we doing? Yes, moons, lots of moons. I've been working on that, since yesterday, sorting out some of the generation errors and kind of fine-tuning what gets generated and where. So I'll probably put a build out tonight or tomorrow, which will have a much better moon generation. In fact, I'll show you what I've done. So before, we were generating moons just arbitrarily, like have some moons. So I've refined just what and where. So the first thing it does is, it first of all decides, is there going to be a moon? And what we're doing is we're doing a weighted Boolean, so yes or no. And we're weighting that random bool based on various criteria. So if it's a gas giant, then we're saying yes, it will definitely have a moon every single time. All the gas giants in the solar system have hundreds of moons. Well, hundreds that we've proven on a couple of them, but probably hundreds on all of them. If you add up all the irregular moons at wide eccentricities. Gas giants just suck in objects, so the chances of them not having a moon is next to none. So we just go for a straight yes, they'll have moons. For other types of body, we are just rolling the dice. Now I've used some of it is just literally percentages I've pulled out my ass, but in some cases it does use real science. For example, in the inner system, Mercury and Venus don't have moons because they are so close to the sun that the sun's influence makes it difficult for them to hold on to a moon. So what we're doing is we're basically just drawing a line in the solar system, which is at 373 Kelvin, which is the boiling point of water. So and again, that's kind of that's a pulled out of the ass one. So we're just kind of defining some point in the system where we decide, okay, anything inward of that line, moons are more difficult to form because of the influence of the star. So I've just taken the boiling point of water as that line. We'll refine that through the actual science over time, but for now, it's a good benchmark. So if it's further out, there's a 75% chance of a moon on terrestrial worlds. If it's within that line, it drops to 10%. Again, we can refine this based on actual science and research as we go. For dwarf planets, we use this definition if they're over 800 kilometers in diameter, in radius rather. If they're less than that, it drops to 1%, because obviously the smaller the body, the less likely it would have captured something. And then similar down for icy bodies. These ones are awkward ones because most of the trans-Neptunian objects have moons, if not all of them, unless I'm mistaken. It seems to be very, very common for trans-Neptunians to have moons. And I imagine that's just the nature of that region of space. You've got lots of icy bodies just knocking about the place. So them capturing one another and forming binary pairs is probably really, really common. So we're just representing that here in the numbers. So that's the first check we do to see whether or not there should be a moon. The next thing we do is to find the number of regular moons. Now, right now, we're only going to be generating regular moons. Irregular moons, as in things that aren't spherical, we'll add those later. But looking at the science, it tends to be the case that large regular moons form close to the planet, and then small irregular moons, which tend to be captured objects, generally occupy the outer regions of that planet's hill sphere. So that's kind of what we're doing here. And quite simply, again, we're taking the the type of planet that we're working on, and then we're defining the number of regular moons based on the size of that planet. And again, that's the maximum on our random range there. We decide where we're placing the first moon. So that's the initial distance for the first moon. I was using an algorithm I found online which wasn't working, which is why the moons were all on top of each other. So I've kind of made my own attempt at it, where basically we are taking the overall hill radius, deducting the Roche limit from it, and taking 10% of that value. And that's basically the range in which we can spawn our first moon. So that's anywhere within the first 10% of the hill radius from the Roche limit. So the minimum is always the Roche limit of the planet, which means that we cannot possibly spawn a moon closer than the planet's Roche limit, which means we won't get any moons in places where they cannot be. And also, because we're only spawning the first one within the first 10% of the hill sphere, then again, those moons are being placed somewhere that is plausible within science. For every other moon, we take that distance for the previous moon, and then we use the Blagg formulation to decide where the next one will be within a random bounds. And we stop generating regular moons at 50% of the hill radius. So we keep adding additional moons one after another, and this multiplier is what most, if not all, of the planets of the Sol system adhere to in terms of increasing orbital distances, but also the moons of Jupiter as well. They kind of fit into the same general organization. There's a lot of debate over the validity of this, and there's no kind of hard science on this, but it's somewhere, it's something to start with in terms of just making sure that the moons are spaced out in a way which is reasonably sensible. It certainly makes a functional planet-moon system, so they won't be kind of overlapping one another. And the cutoff for regular moons is half of the hill radius. Beyond that, you would expect to find irregular moons. So we just loop through until we hit our cap that we specify here. So we're defining a lot more than we were on the last build, on Friday's stream. So we determine our radius, and we are starting with the cutoff in which something becomes spherical. So there is obviously a radius slash mass where an object can reach hydrostatic equilibrium, where it sphericalizes, and that's generally around about 400 kilometers in radius. It depends whether it's an icy body or a rocky body. Icy bodies tend to sphericalize smaller, but just for the sake of our initial implementation, if we just go with 400 kilometers as our initial cutoff, then we know that that's definitely going to be spherical. And what we then do is we take 50% of the planet's radius and we apply that as our maximum, unless that is in excess of 3,000 kilometers. So we don't allow moons to form larger than 3,000 kilometers generally. Now we will tweak this for gas giants. Obviously we want to be able to have something like an Earth-sized world orbiting a gas giant, but for now, again, just for testing purposes, we'll limit that to 3,000, which is about half the radius of Earth. And again, no moons larger than half the radius of the planet, and it will just pick a random radius within those bounds. So that gives us reasonably good-sized moons. We then just do the Roche limit calculation. We are using the density of our moon as kind of our benchmark value. Again, the percentage of iron content in the moon will increase its density, but we're just going to take a typical density of our moon as our value. And then we work out the hill radius. Generally speaking, the math here expects it to be a planet orbiting a star, but we can just plug in the planet details instead of a star to get the hill radius of the moon. And that's pretty much it. The rest of it's just the usual stuff that we do for planets. We've been able to plug a bunch of these values in. I've written a few helper macros just to be able to do unit conversions. Just input the radius and the density, get the mass, that sort of thing. Yeah, so that should be that. The class of object right now, we are basically using dwarf planets as our moons. So those are just dwarf rocky worlds. We don't want to only have those as moons though. So as I iterate on this, I'll start bringing in the equilibrium temperature of the region to determine whether it's going to be an icy moon or icy body, or whether it's a rocky body instead. So we can look at that. So there's a lot of additional iteration that we can do to this to refine the system more and more. But already it's forming much more believable planet-moon relationships than it was before. The other thing I did was I've fixed the planet atmosphere being rendered behind moons with a trade-off, and the trade-off is that you cannot see the atmosphere if you are within it. Now right now that is an issue because you can fly within atmospheres. Moving forward it won't be, because the ship won't be able to enter the atmosphere anyway. You'll have to transition with a shuttle for that. So the outer edge of the atmosphere is always going to be as low as you can go over planetary terrain. We've never designed it for the main ship to go within the atmosphere, so ultimately, although it doesn't look as good when you're within the atmosphere, from within space it solves the problem. In fact, if I grab our planets playground, I'll show you what I mean. So here's a couple of planets. As you can see, they cast shadows on one another, which is nice. But now the atmosphere can pass behind the object, and it's no longer rendering through it, which is good, because that didn't look great. And if we go and put the camera inside, maybe I can get it there. See, when you're low down, it's fine, but it's difficult to move when you're this close to it. Not sure whether I'm going to be able to get it down there. But yeah, it will clip off basically. So when you're within the bounds of the atmosphere, you won't see the atmosphere, but it will persist right up until you clip through the mesh. So you can do low-level flybys, but you can't fly within it. But right now, that's kind of a necessary evil now that we have moons, because otherwise you have atmospheres showing through stuff. And it also means that we can have multiple atmospheric worlds in the same environment. So you could have a moon with an atmosphere on top of a planet with an atmosphere, and these atmospheres will all play nicely next to each other without all overlapping, which doesn't look great, but it kind of enables us to do kind of planet rises over moons without it all shining through horribly. So I fixed that as well. Yeah, Ganymede and Titan are huge. if we just quickly drop into the game a minute, I shall show you what the new moons look like. So within the Sol system, there's our moon. So this is an 8K texture sourced from NASA, and apparently this is a 2026 image from NASA, so it's a recent one. Nothing to do with Artemis, but it is a recent image. It's got some good coloration on it, which is nice to see. Unreal can't import anything bigger than 8K, or at least it didn't used to be able to. So we can't go higher resolution than this in terms of textured planets. When we do procedural generation, it's kind of irrelevant. We just generate whatever we generate. But if we're just applying a global texture map, then the limit is 8K, which gives us this. But I mean, it's decent enough. And in the Sol system, there is only the one moon. So I've only added Earth's moon. I will add the others at some point, but for now there's just that one. In all the other systems, they will just be procedurally scattered. But the interesting thing is, and this fascinated me, is the size of our moon compared to the planet is actually tiny. There it is over, I don't know whether you can see it, but that's the moon right there. And it looks tiny, but it is actually the same size as the sun disk. So the sun disk is actually just that little bit there, and the moon is the same size. And the reason they're the same size is why we get eclipses, because they're literally the same size in the sky, despite being vastly different object sizes and distances. But the reason it looks so big in the sky from the surface is because we're always comparing the size of it to objects on the ground, which makes it look a lot bigger. But that is in fact the correct size and correct distance. It really kind of puts it into perspective how far away it is, and how small it is. We'll just fly over there a minute and we'll have a look. We will get there a lot quicker than Artemis did. Yeah, Earth's moon is 26% the radius of Earth's Hill sphere, which is actually really unusual for moons of this size. Most of the other regular moons in the solar system are like within 5% of the Hill sphere. So for our moon to be this far away is actually quite unusual. But it looks good, if I say so myself. Yes, Mad Dementor. It should do, Doubter. I'll have a look in a sec. Let's see if I can just do a moonrise a sec. Earthrise, rather. Just make sure that it works from distance. Yeah, the one downside to the NASA texture is that the moon's polar region has a much lower resolution to the equatorial region and the higher latitudes. I don't know why that is. There's probably gaps in the data, but yeah, I'll see if I can do something about that. It's nice to see the actual moon though, and be able to just kind of explore it like this. There's Earth. Yes, that was fine. So none of that shone through the surface. So problem solved. You got a giant whip note on the moon. I think I've got it facing the right way. Let me just check. I specifically told it, yeah, it looks about right. I told it to face the Earth. Obviously it's tightly locked, so I think that's the right side. Right, if we pick somewhere like Alpha Centauri, pick a random planet, that one will do. And then we'll cheat our way over. Yeah, you're probably right. It was yeah, probably just the where the I think it's the LRO, isn't it? Lunar Reconnaissance Orbiter. I think that's what generated all this. Right, I just sit down there a mo. This moon must be right on the edge of the planet's Roche limit. Although saying that, maybe not. So good to see moons in the game. We've not had them for so long, and in the end, getting them implemented was nowhere near as complex as it could have been. Yeah, nothing drew through anything there, so that was good. Yeah, the other thing I need to check actually is I need to make sure that the moons they're all on the same orbital plane as the rings. They should be orbiting around the planet's equator if they were co-formed objects. So from what I've been reading, regular moons tend to be co-formed with the planet. So in the same way that a sun will coalesce into a star, the gas coalesces into a star, and then the rest of the gas coalesces into planets. That's also happening at micro scales as well. So you'll get lumps of gas coalescing into a planet, but then also moons at the same time. That's something I need to look at, Illusion, is making sure that our rings are within the Roche limit. Obviously you can get rings formed by collision outside of that, but generally they'd be within the Roche limit. Is this the only moon? We don't have labels for moons either, that's something else we need to look at. But see, it looks like it's above the plane of the planet. So yeah, there's going to be some math I need to do there to make sure that they line up properly. I think what might be happening, I think they're actually perpendicular, so it's orbiting perpendicular to the equator. Can't see any others. Hang on, let's speed up and see whether we can see one moving. Usually you can see the little dot. Yep, that one just had the one regular moon. All right. Yeah, and they really shouldn't be, so it's definitely something to fix. Yeah, so you can see here the inner planets, because of the low percentage, didn't generate any moons. So it's not impossible, just not as likely. This one has 2 moons though. Let's go and have a look at that. Yeah, so to answer the earlier question, yes, we will indent these. So what I'll do is I'll make these list items slightly smaller so that we can indent them again by the same amount. So you'll have the moons indented under the planets rather than showing alongside them like this. And this indication here, where it's giving you the distance it's actually displaying is distance from the planet, not from the star. So we need to make sure that we sort that out as well. And the other thing I want to do is make it so that when you dismiss the NPC and you just hover your mouse on like that, left clicking is not doing anything because it's trying to sit me in the chair. So I just need to make sure that it brings up the summon NPC option. Lots of little tweaks and fixes are needed to make sure this is like a super smooth system. Almost rammed it. Yeah, so we just need to make sure that the moons that are spawning are viable in terms of their mass and their position in orbit alongside other moons, so that it wouldn't kind of like perturb the orbits and result in a non-stable system. I guess we're going to have to take some example systems and maybe plug them into Space Engine or something and see whether or not they are Universe Sandbox and see whether they are actually viable. I mean, looking at them, they feel like they're too close. I mean, we know from the math they're definitely outside of the Roche limit because we've set that as our absolute inner bounds. So they're definitely further away than that. But yeah, they feel a bit close. I mean, from the surface, this moon would be huge in the sky. Okay. Yeah, so the 2 Lagrange points and the Lagrange clouds that are both ahead and behind a planet in its orbit, we'll have that modeled at some point, and we'll have wispy Lagrange clouds, which Earth has. I never realised. I mentioned this on a previous stream. I thought the Lagrange clouds you get in Elite Dangerous were kind of just a because it looks cool kind of thing. I didn't realise they were actually a real thing. Earth actually has a very wispy Lagrange cloud, which I thought was quite cool. No, I think it's good, CSI. I have checked, but if it was meters or centimeters, then the object would be inside the planet, which is what we had originally. And yes, we will have moons of moons at some point. Yeah, so in order to help with validating our moon system, I thought it would be nice if we actually added some of this data to the Holo-Display. So for things like hill spheres and Roche limits on planets, it would actually be nice to see those represented on the Holo-Display. So I figured we can add those as a data overlay, so that we can make sure that that the moons that we're looking at are indeed where they should be within the planet's orbit. So we kind of need a flag on our large system object. As much as we've got moons as a data point, we also kind of need a flag on those just to indicate that it is in fact a moon. Because when we do our listing, this is that collapsed graph I didn't rename last time. Combine planets and moons. So what we're doing is we're taking all of the planets within a system, and then for all the moons of those planets, and we are constructing a common struct that holds all of them, so that we can display them all properly in one looped array. But I think it would benefit us to have like an isMoon boolean on here, so that we can do different things with them on the Holo-Display. Like when we spawn the orbit ring, right now the orbit rings are spawning within the central star because they're just going off of the semi-major axis of the moon, and of course that's in relation to the planet, so it's tiny, and within the bounds of the star itself. So having a flag on there means that we can draw those with a different origin point. So I think we will go ahead and do that. Yeah, and then armed with that, as we go through and we draw each planet and draw a ring, yeah, so we'll add another layer of data, and for that we need our dotted line render, so we will do that. I'm wondering whether I can maybe macro this, because I've made a macro for orbital rings there. Why are we not doing it there? Yeah, so really that's a badly named macro because it's not actually what we want. Add region. Okay, so what we'll do is we shall add a dotted line with a label around the planet, one for the Roche limit and one for the Hill sphere, so we can just see the gravitational influence of the planets on the Holo-Display. And I suppose we'll align those to the orientation of the planet, so we can also see like whether the planet's like up on its end, like Uranus is, or is it Neptune? Which one's on its side? Can't remember now. Alright, so if we just grab a copy of that. Collapse all these down for tidiness' sake. So I'll probably draw this for the object itself as well. So we need an origin point. So rather than the root location, we want the offset of the object itself. Which means we could do with an option to add that. So if we're not using an offset vector, then we'll just give it its root location. Otherwise, we will add the root location to the planet location, and then we'll use that as the source for the spline when we draw it, and then we just draw around that. Yeah, that's fine. Okay, so these ones don't need it by default, but these ones do. So we need the local chords as our offset on both of them. So that one would be Roche limit, and that one would be the hill radius, and then we'll give them some colors. Guess we'll make both of these the same color just to have them match. Okay, so the semi-major axis is going to be the Roche limit in that instance. Probably need to convert that to centimeters. Okay, yeah, and that radius is just making sure that we're not drawing it inside the radius of the star. Which is awkward if we're not drawing it around a star. So if we just use this again. In some ways it probably would have been better to use a separate macro, but I'll do this instead. Yeah, so if we're drawing a temperature region around a star, then we want to make sure that if the semi-major axis of that region falls within the boundary of the star, then don't draw it. So that stops like lava zones being drawn inside stars if the star's not hot enough to create one. Yeah, and if it's not a star, then we'll just use that radius there instead, which means we need to give it something from there. So we want our body radius. I think that's okay as kilometers. And then we need hill radius for that one. Body radius remains the same. And both of them need to use an offset. Right, let's just see what we end up with. Stopping drawing it too quickly. Should be sticking it on there though. Yeah, so the moon there should be on the orbital plane, and it's not, so that needs sorting out. but it's not drawing any lines. So let's see if we can work out why. Yep, I just throw it together and see what sticks. Yeah, there's a few more hoops that need jumping through for that, but yeah. Too many tabs. So I'm assuming then that it's probably the offset that's not working. Okay, so as a test, let's set this up and oh wait, hang on a minute, we're converting that already. That would make a difference. Just do a quick test a minute. Otherwise I'll make a separate macro for planets than stars, just to stop it getting confused. Still not seeing anything drawing on there. Yeah, so interestingly, that's the Roche limit of the star, which is actually a lot closer than I thought it would be. Let's just see whether it generates a hill radius, which is going to be huge if it does. No, don't think we're able to zoom out far enough to see it. The hill radius is like 2 light years or something. Okay, so let's check that. Hey Melissa, good to see you. Right, I'm going to override the optimization so it forces it to draw everything. and then we'll see what we see. You should post a screenshot of that on Discord well today. It's no longer possible after the next build, so grab it while you can. So it's not that. Is it this instead? So again, this is the optimization to stop it drawing when it's irrelevant. So let's just see whether or not the optimization's actually the thing causing the issue. It's usually one of two things. It's either the optimization being a little bit overzealous, or it's my terrible math. Assuming in this instance it's the terrible math. Yeah, because it's not drawing anything there. Oh, hang on a minute. Okay, so this is going to be the hill radius of each planet. Okay, and they're not centered on the planet itself, which is going to be the offset causing that problem, which is, I'm guessing we have a bunch of Roche limits as well. Yeah, so there's a whole stack of Roche limits in the middle of the star, and what I assume is orbital rings for the moon. Actually, the orbital ring for the moon, because the ring isn't being offset. Okay. I'm assuming then that outer hill radius is probably Jupiter's, which is massive. So if Jupiter was in the center of the star system, it could in fact capture Venus. Barely, but just about. Mad. Right, so if we... So we know that it's drawing, but it's drawing in the wrong place. So let's just see what we're calculating that as. I imagine this will be one of them centimetre to kilometre things. Okay, so yeah, so that's in centimetres, blah 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 blah. Right, so the offset, or the root location rather, is definitely in centimetres, which means the offset also needs to be in centimetres, which it should be because it's in local coordinates. Which is weird. So So if that's where the spline is, yeah, so this is actually irrelevant because we don't need to draw an actual, like an eccentric ring. We're just drawing a circle. So we don't need any of this. So that's actually irrelevant. So what we actually need to do is we need to take our root location, which in the case of a star is literally our root location. So we've added a spline point there. Yeah, so I'm going to have to make so much of a change on each one, but it actually will be easier to do a separate one for planets. So we got our display radius and our range. And we want to make sure that the ring's at least 10 centimeters in size, like in screen size. And then then that's our max range. So I think what we'll do is we will ignore the max range for now. We don't need to worry about root location. We only care about the location of the actual object. So this would be planet coords. Okay, so get rid of that. Although I'm going to keep that handy. We can get rid of that. Pop that straight in there. We'll worry about that afterwards. So that just defines our smallest size it can be. So add the spline, draw the circle. So that will be positions around the circle. So for each one of those, we want to take I remember why I did this now actually. It's because when we draw the points for generating the spline for the circle, obviously there's going to be an inclination involved, so we need to make sure that we grab that from the planet. So we don't want the system inclination. Oh, that's just getting the star anyway. Yeah, so we'll grab that from there. So Let's make a new one of these a minute. Just do a generic one for Roche limits. Where did we hide inclination? Ah, there it is. Okay. Yeah, because we want those dotted lines to match the rotation of the planet. Right, so we're spawning that there. Yeah, so this calculate orbital properties is assuming a root location of 0, 0, 0. Yeah, so I would have to offset that by that distance, so it's probably easier if I just offset the output instead. So we would add the planet coordinates to the output of that, just so we offset it to where the planet is. That just makes sure it stays within the bounds of the map. Okay. Right, let's give that a try a minute. I suppose before I do that, we'll just fix this one. So same as before, so we'll get rid of that and that. That can go back over there, so we don't need that or that or that. That can go back on there. So that's that one there, and that is greater than that. Okay, so that's just again handling the minimum display range, and we won't bother about maximum for a moment, just to be sure that it actually properly draws. I don't think I changed anything there. No, that's still fine. Oh, I suppose I could. What are we using that for? Oh, I see. It's the overall rotation. Okay, so we will need that on the other one. Just pop that in there. So there's a bug with collapsed graphs in that you can no longer access local variables if you collapse the nodes on one of these. So if you're inside a function and you collapse the graph, then you can lose access to local variables, which is frustrating. Okay, so is it drawing the rings in the right place? Oh, I can see a ring, so that's a good start. Okay. Yeah, so we need to sort out the system inclination, but are they? Oh yeah, they are still the same way around. Okay. Yeah, so that is the Earth's Roche limit. I notice it's not drawing the text label, so I don't know where that ended up. But yes, so there's the Earth Roche limit. So the moon is obviously well outside of that. So if we look at the other planets, there's Mercury's with its tiny little Roche limit. I'm guessing Jupiter is going to have a massive one. Yeah, quite big. Okay, so we need to rotate that now so that it's in line with the rest of the system. It's quite interesting to see, though. You know, that is the extent of Jupiter's gravitational influence on the system. Yeah, and then that would be where things would get ripped apart, which is interesting because you'd expect a planetary ring to be beyond that. In fact, if we look at Saturn, willing to bet Saturn's rings are most likely outside. Yeah, so Saturn's rings are definitely outside of its Roche limit. I'm going to make sure I double check the calculations for that, because I mean it looks a little close. I mean, you'd expect like a moon-sized object to get ripped apart by tidal forces well beyond that line, but if the math is right, then the math is right. Right, let's grab that value. got that as an input, and it would have been the text label. Yeah, so same thing here, where we need to add our details to that one, so that can go in there. It's going to be a bit spaghetti-ish, but just to get it working, let's just plug everything in. And I'll tidy it up afterwards. Right, that should at least get the writing in the right place. And then this should sort out the rotation. Yeah, so in actual fact, having the local variable shouldn't be accessible, because this is a macro, and obviously I've collapsed a graph into a macro, which means it's retained reference to a local variable within the function that the macro is being used in. If we were to use this macro outside of that function, then this variable wouldn't be available. It would be a null reference. So it's correctly not allowing me to duplicate it. So if I copy it, all of a sudden it doesn't exist. It's magically retained a reference, which is interesting. Okay, that's perhaps a little bit more promising. Maybe. Yeah. Hey, don't worry about being late. I'm always late. Thank you. And yeah, this is my test map. So there is no back of the ship on the test map. Okay, yeah. So the ring that's being drawn is now on the correct plane, which means the math checks out. Let's make sure we're zooming on the right thing. Yeah, so there we go. So you can see Jupiter's direct influence on the system. Although I'm pretty sure that Jupiter is slightly pulling on the Sun. I'm sure that the Jupiter Sol barycenter is actually outside of the Sun. Although I guess the whole point of a Hill radius is that anything beyond that experiences a greater attraction from the Sun than it does Jupiter. So I suppose that isn't Jupiter's area of effect specifically. It's where the Sun becomes stronger. So I guess that makes sense. That's why it's not all the way over here. I suppose given that gravity travels at the speed of light, I suppose there isn't actually an end to how far gravity will reach. It's more a case of where does something else become stronger. No, there are no transporters or teleporters or anything like that. The closest we'll come to it will be an artificial wormhole. Okay, so mission accomplished, really. So the whole reason for doing this is we want to be able to see where the moons are on exoplanet systems to make sure that they are being generated in sensible locations. So again, just pick a random planet and go there. And then cheat. Okay, there's our planet. So, looking at this now, but let's do a quick survey while we're here. Odd. Why do we have... We've got a bunch of rings which are offset from the orbital plane. I'm guessing those are rings from moons being drawn incorrectly. Okay, so we start with that one. So this one has 2 moons. Okay, so that's good then. So we've got the Roche limit of the planet. And the moon is definitely generating well beyond that, as is the other one. And then if we zoom out a bit more, you can see they're both well within the hill radius of the planet, which is nice to see. It's nice having these values on here for troubleshooting reasons, because it means that we can validate that the position of the moons and things are legit. You know, they could realistically exist there, and you know, they're outside of each other's influence. So you're not going to get one moon affecting the other. I'll change the draw distance on that a little bit so it draws sooner. Hello. A wild Claire has appeared on the floor. Hello.
Came in to see my bird, but he seems to be asleep.
Did you hit your head?
Oh no, Garfield got me.
You're literally bleeding from your head.
I know. Can I let everybody know?
Yeah.
How mean my cat is.
Can they even see you?
Look, can you see the blood? Mean cats. That's why I don't like cats.
So why were you putting your face in the cat?
Because I went to kiss him and he didn't want one.
Wow.
So I thought I'd come in and see the bird instead, because he's nicer to me. But he's asleep.
I haven't told you about the bird. So we have this thing where we keep rescuing wild animals. They just keep turning up. So yesterday we have a seagull that was outside of the house, just standing there and not moving. So one of our kids brought the seagull in, just like holding a seagull, legs dangling away, and the seagull is now on my little sofa in a box, currently asleep. But I don't think it's got much of a future ahead of it. It's not making any noise, and it will only eat or drink if you like force feed it. And we think it's got neurological issues. I mean, it's not a well seagull, is it?
No, it's not very well at all.
So
although it's got a little bit better this afternoon, so we'll see how it goes. But
yeah.
Yep. As you said.
Luckily, we've got like bird food, like liquid bird food and feeders and things, because this will be the 4th wild bird that we've had to kind of hand rear and look after now. If there's no improvement within a few days, we'll just take it to the vet.
Yeah.
And we know what the vet will do.
I'll give him a chance first.
Yeah. But yeah, it's never dull around here. There's always something. So yeah, Claire is currently looking after a seagull. It's weird seeing a seagull refuse food, because normally they're quite the opposite. Thanks, Delta. Yeah, it's being most un-seagull-like. It's not eating anything right now. Although Claire has managed to feed it with a syringe, so that's good. Just making sure that it can like actually swallow, because Claire's got quite good at it now. She's
I'm a mummy bird.
Yeah, she's a mummy bird. She knows all about like avoiding aspiration and making sure their crops are full and all that stuff. Actually, it's the first time I've seen it sleep properly since yesterday.
Yeah, I was going to bring it over, but I don't want to disturb him.
Well, if he wakes up, you can introduce him to everybody.
Sure.
So, I've named the seagull Kihar, and if anyone is familiar with Watership Down, you'll know where I got that from. Like all my cats are named after rabbits from Watership Down, so it seemed fitting that I should name the seagull after Watership Down as well. Let's go have a look at that one, actually. Have I discovered a bug? Why are they not navigating?
There you go, Dan. Seagull.
Ah, hello. Seagull. He's more active now than he was yesterday. That's good.
Bring it back again.
Hang on. You
I can't get up.
Big screen. There you go.
I'm too low down.
Oh, that's so cutie. Oh. There we go. That's our rescue seagull. But he's not very well. There you go. Put him back in his box. He's so much stronger than yesterday, though. Like yesterday, he was just like sat there with his eyes closed the whole time. He's really perked up, so that's good. Hopefully, we can reintroduce him with all the other seagulls. Yeah, it's nice to see he's got some fight in him. I was quite worried yesterday. It's interesting. So, were we already at that location? Perhaps that's why we weren't going there. Oh, we were. All right, it wasn't a bug. It was just me not knowing how to play the game properly. Yeah, you're right, to be honest, Firstus. He's suspiciously tame. They're not normally that chill. So I do wonder whether or not he's been hand-reared in the past, because he really doesn't seem to mind people at all. Where did the planet go? Okay, so there's the other moon. How do you lose a planet? Yeah, things like cloaking technology, artificial wormholes, anything like that, it is beyond the human race in the time frame that the game is set in. So that'll be stuff that aliens might have, and at some point technology that we can reverse engineer. It's really weird, I've completely lost the planet. Wow, there it is. Yeah, I'd say they wouldn't necessarily share their tech with us, but if organisations like Lunara are anything to go by, then they won't be sharing it by choice. Plus, we'll be doing salvage operations. We'll have alien derelicts and things in the game, and once you start picking apart alien derelicts, you'll discover all sorts of stuff that can be retrofitted and researched. I know practically nothing about Mass Effect. That one has escaped me. You've got to love a Planet Rise. Right, okay, so I reckon that they are drawing at reasonable distances, which is good. It's interesting that you can see the moons in the distance. So let's turn off labels a minute. Yeah, so for other planets in the system, you can see all the moons around them, and I'm thinking it's probably going to be a good idea to make them a lot dimmer than the central planet, because it looks a bit weird having those little clumps of bright dots. Let's just go and fly over to a couple and have a look. Doesn't help that we're running in the editor and it's never quite as well rendered, like in terms of anti-aliasing and such, and it's also a lot more jittery as well. It's fine when packaged. There just seems to be this issue running in the editor. Oop, loop of shame. Yeah, the way that the star calculates its light is that there is a single light source that is shining in one direction, which is always towards you. So if there was something immediately behind the star, as in the star's between you and it, the star won't be lighting it because the light is facing you at all times. So anything in the distance is lit basically just as a solid white dot, just to make sure that it's actually getting some light from somewhere. This one seems to have rendered its moons quite far away. So which one is this? That one, okay. Okay, so oh, that was interesting. I was looking at that then thinking, hang on a minute, you've got 3 moons here with overlapping radii, but it's not. It's that they're spread apart, but the orbital plane is aligned. It's obviously aligned to the system plane, not necessarily the plane of the planet. And it also means that if that is the orbital plane of the system, then we are drawing the orbit of moons perpendicular to that almost. So that needs looking at as well. Okay. All right. Let's see if we can sort that out. Again, I guess we need that flag, don't we? Yeah, Vulcan is just literally as is. it's part of Unreal. Vulkan's one of the RHIs you can select. We've done nothing to it. We're just making it available literally as is in the engine. So if it doesn't work for any reason, it's part of either the implementation of Vulkan in the engine or something to do with the GPU drivers on your local card. We literally have no involvement in it at all.
It's usually the drivers. People have had to roll back to the previous one because it's been awful with the new one.
Yeah, as Claire just mentioned, some of the most recent drivers for Vulkan have been really bad. So try rolling back to a previous driver. So we need a moon version of this, basically. That takes a different inclination. Yeah, so we get rid of that one in a minute because it's confusing things. So there's no, there's no direct way that we can flag whether it's a moon, literally without flagging that it's a moon. So we do need to go and add to that struct. So if I save all a minute. Yeah, so we're looping through this. Which means we absolutely need to create a flag on this one. The reason I'm kind of hesitant is because we do store moons with a separate struct. But when we loop them on the Holo-Display, we use that same struct. So it just makes it a little bit awkward. And then on here, so when we're going through moons specifically, we can flag that as true. We don't need the flag on there because that's implied by the fact that that's the moon struct anyway. When we do the data structure for multi-star systems, this is all going to be one large struct anyway. So we'll have moons, barycenters, stars, planets, all part of the same struct with the same structure. And because we're using parent and child IDs, we can do nesting based on that rather than having a struct array to pull from. So we won't bother with this child struct at all. We'll just have parent and child relationships. Treat it more like a database, basically. But for now, that should at least get us to the point where we are flagging that it's a moon we're talking about. So I guess in that regard, let's do it on here. So trying to get my head around the orientations with this. So if moon is true, then the system inclination needs to be the planet inclination, which means we need to do a select on that. Right, let's tidy this up, shall we? Because it's all a bit messy. So we're using this in 3 or 4 separate places, so wherever that's used, we'll just connect that to the same line. Again, just to keep it all neat. Okay, now we've got that inclination as well. Okay, it's a bit less terrible. Right, so if it's a moon, then the inclination would be 0. If it's not a moon, then it's the inclination of the planet. And then similarly, I guess we're going to need this multiple times as well. Okay, so if it's a moon, then the system inclination is the inclination of the planet. Otherwise, it's the overall system inclination. And the same for that. So the moon is in no way inclined. Yeah. That should do that. And then we need to do exactly the same thing here. So if moon is false, we use that one, which would also be that if the moon is true. And then we need a copy of that for there. Once we're satisfied that all this is working the way we want it to, then I'll start collapsing this and tidying up a bit more. But just need to get it working first. I'm not a fan of blueprint spaghetti like this. I always kind of make an effort to try and tidy it up, but in instances like this, when you're dealing with macros, it's often a little bit more difficult. Okay, let's try that. So basically what we want is we want the orbital lines for the moons to have the same inclination as the planet's equator. Hey Sirius, good to see you. So we'll hop straight into Alpha Centauri, pick a random planet, go there, cheat. Okay. Need to work out what those orbit lines are as well, because they should not be there. Okay, so yeah, so that hasn't quite gone to plan. We want the dotted line around the moons to be aligned the same way as that is. Although, that said, if this planet is inclined that way, then in actual fact that is correct. I guess we need to see the inclination of the planet. Yeah, I suppose in that regard, these lines do need to match the planet inclination as opposed to the system inclination. Okay. Another good use for this hill radius, by the way, is when we start generating procedural content in and around systems, the system will be split into cubes, and each one of those cubes can spawn content within it, and that content is going to be generated on the fly. It'll be seed driven, so it'll always be the same each time for a given system, which means your friend going to the same system will see the same stuff. But it will be generated on the fly. So as the ship approaches, the procedural system will be generating that content. So it won't be pre-generated in the same way that the planets and the moons are. Now we want to cluster content around planets and points of interest within the system. So having a hill radius like this around a planet, that kind of maps out the area where we'll be spawning interesting things. Not exclusively, because there will be stuff just generally within a system. Like there could be just like a drifting alien derelict that just could be drifting in space. But generally speaking, more often than not, things that get spawned will have an increased chance of being spawned within the hill radius of planets. So you know when you're out there snooping around looking for things, that's where you would be looking to find it. So you know that there's a greater chance within that circle of finding something. So it's a nice visual indicator. I suppose we could render that actually as a sphere, the same way we do with the temperature regions. So they're actually proper spheres. But that's something else to add to the to-do list. Right, let's fix the orbit lines for the moons, because obviously they shouldn't be there. Okay, so in a similar vein then, adding this orbital ring, this is going to be the same as with these, where we could do with adding that flag, because if it's a moon, then we need to offset those coordinates. Let's just give these some meaningful names. Okay. So we're not worrying about labels on this one, so it's literally just drawing the ring. So really it should just be that offset should be all we need. And just making sure that these details are correct for the moon. Guess we also need to make sure we add correct route location as well. So yeah, so let's do a couple of select statements. So if moon is false, we'll just take the route location. If moon is true, then that's going to be route location plus planet location. Yeah, let's just stick that on there. Why did it call it B? Actually, we're drawing it around the... No, we're not. No, we are drawing it around the planet, aren't we? Need to make sure we have that available to us as a reference. Otherwise, we can't do this. Because this is the details for the moon, but we're not going through each of those separately. So I guess what we also need then is the local coordinates of the parent body. Because on a planet, generally that's going to be 0 because it's the location of the star. But for a moon, we're going to need parent coordinates on here. And then when we do this loop on here, the parent coords actually need to come from this object, so we can just plug that straight in. So that's the coordinates of the planet, and then obviously we add each moon on top. So that gives us that, which means when it comes to what are we doing? Ring. We can just plug the parent coordinates in there. So that gives us that information, which means we can rename that. Okay, so we're basing our spline with the parent coords as an offset, but we also need to do that here as well. So for every spline point that we add, and also that needs to also be a select. So let's just move all this out of the way a little bit. So if moon is false, we can do that. Otherwise, we need to offset based on our parent coordinates, like so. And then we'll just pop them up there. Keep it all neat like. Right, so that should do that. And then we're already getting the orbital characteristics anyway from that root object, so that's fine there. Oops. So those should be correct for the moon. I think my only concern is that we might be doing a centimetre to kilometre mismatch again. But let's render it and see. So if we look at Earth on the short range, what we're looking to see is an orbit line for the moon, which we're not seeing. So there's the moon over there. Not seeing any orbit lines. So does that mean it's in the sun, I wonder? Yes, it is. So that's that'll be the moon's orbit there. Right then, why is that doing that? Okay, so just make sure we're flagging that properly. So setting it true when we loop the moons, we've got our parent coordinates there from the planet. Parent coords there. So is moon true root location plus that. If moon is false, just take that. If moon is true, add that. Curious. Let's put that there just so I don't get confused. Basically, we're adding spline points around a circle, and that circle is defined by the orbital characteristics. And then we're taking the minor and major axis from the moon's orbital characteristics, and they are relative to the planet. So Yeah, so adding the parent coordinates to that should be more than enough. Make sure we're actually adding the local and not the galactic coordinates. Oh, I see what I've done. I see what I've done. It's the local coordinates of the planet that goes into the parental coordinates of the moon. I was basically sending 0 as the reference there. So there we go. Now it makes more sense. Okay, so we now should see an orbit line on the moon. Yeah, there it is. Okay, so that's the moon orbiting the Earth. Now I think the inclination of the moon's orbit is wrong, so I need to go through and figure out what's going on with the inclination there, but that's sorted that out, which means it should also be sorted for all the exoplanet systems as well. So if we go and pick one of them again. Okay, Melissa, enjoy. Okay, that's better. We're not seeing crazy lines everywhere now, so that's an improvement. So if we pick one of them, which one's got lots of moons? That's got quite a lot of moons. Let's zoom in on that one. Starting to make more sense now. Starting to look like a proper Ori map now. So I think one other thing I need to add to the generation of this is that when we are placing moons, we need to make sure that we capture the hill radius of the moon previous. So obviously we work from the inside outward. So we place the first one here. When we then define the next location for the next moon, we're making sure that the minimum is the hill radius of this moon, but we also need to include the hill radius of the moon we're adding next to make sure that the two hill radii do not overlap, because if they were overlapping, I imagine that would cause issues with the orbital system, and it wouldn't be a stable system. They'd be basically each moon would influence the other until they achieved some kind of equilibrium. So if we make sure that none of these hill radiuses overlap when we draw the system, then if you were to model this and put all the numbers into something like universe sandbox, then it should be a stable system. They shouldn't be interfering with one another. But we'll have to experiment with that and see. But yeah, I think that's pretty much working as intended. I think the lines... Yeah, the lines for the hill radius are ever so slightly off. Yeah, they are a little bit off. So I won't do it now because it's going to mean a lot of poring over the math and just making sure everything's lined up. But I need to just make sure that all of these inclinations are all aligned with one another. And right now we're not adding any kind of inclination to the moon's orbit. So we can add some randomness to that, just to get moons that are slightly more inclined than others. Yeah, but that aside, I think we're starting to get there. At least we've got actual working systems now around each planet, which is nice to see. So on the to-do list, we need to indent the moons on here. We need to decide what type of moon. Is it icy or rocky? We need to change the wording so it says from planet rather than from star. And at some point, thank you, Delta. I wanted to add a better system overview so that you can see the relative size of each object, like alongside one another. So we can find an example. Yeah, I guess something like this. So on the Holo-Display, we can actually just line up all of the objects in the system, just equally spaced apart, so that you can actually see physically how big those objects are compared to one another. Right now, parking next to a gas giant and then parking next to a small Earth-like world, they look the same size out of the window because you are relative distances away to keep it the same size. So the approach distance is basically double the planet's radius, or 1.5 times the planet's radius. So that distance is obviously further away for big planets than it is for small planets. But the net result of that is it's always the same size out the window, regardless of how big it is, because you're scaling your distance by the planet's radius. So by having a display like this on the Holo-Display, you can actually see at a glance properly how big those planets are in relation to one another. So you can have more of an overview of that system. It's just a case of deciding like how best to present that on the Holo-Display, because we don't have a lot of space to play with. Maybe we could do it in a circle. Maybe we have the star in the middle, and then a circle of planets around it, equally spaced, all their different sizes, with all their moons stacked on top of them. That could do it. And then we just need a button on here to show that. And we could potentially even colour them in as we go, as we do scans. But it's an idea. Yeah, a bit like the Elite Dangerous one before they added Ori maps in. Let's give it a try. So if we did where's our function for the Ori? There. So if we duplicate that map, just did something like that. Then we wouldn't have any orbit lines or temperature zones or anything like that. It doesn't need to have like display ranges or pretty much any of the complicated math that we've got for the Ori map. All it would need to have is a big ball in the middle for the star, and then a ring of objects around the star. Okay, let's give it a whirl and see. I've not actually seen that binary. I'll have to have a look. That's the thing. Over the past 5 years, really, I've spent all of my time making this game rather than playing other games. So I'm kind of behind the times when it comes to what all these other games have. We're on the right one, so we don't want any of that. Don't want any of that. Yep, don't need any of that. Keep that. Don't care about targets. Don't want to render them. Okay. Frost lines and stuff, don't need any of that. any of that either. Okay, so we still want to do that. And I guess that's irrelevant. Hey Joe Coffin, how are you doing? Okay, so we don't need any of this because we're literally just drawing a few balls, so we don't need to worry about display range. Yeah, so let's just get rid of that for a minute. So if we add static mesh, add static mesh component, I suppose we need to base this on object type.
Bye.
You off?
Yeah.
Bye. We have a happy sleeping seagull, and Claire's off back to the house again.
Bye, everyone.
Okay, so the scale of the star, obviously we can get from the radius. So if we get our physical characteristics, so that gives us our radius. So if we just add a normal sphere, so we want the basic shape one. Don't want to use some random one. Basic shape sphere should be 100 units wide. Yes, 100 by 100 by 100. That's important because we're going to use that for our scaling. So our scale there is going to be difficult math. So 1 is obviously a radius of 50 centimeters. So we need to convert kilometers to centimeters so that we're dealing with the same scale. So if we wanted to divide so we wanted it to be 1 meter, we'll divide that by, well, I suppose 50 centimeters, divide that by that, then that gives us our relative scale. Hang on, that's going to be a really tiny number, isn't it? So like 300,000 kilometers in centimeters. Is going to be tiny. I'll get my head around that. To begin with, let's just spawn the star. And then for each object, well, actually, before we do that, there's a couple of things we need to do first. If we do a for each on this to begin with, first of all, we need to work out how many planets there are. Yeah, so if moon is false, then we'll make a local variable. So we want planets as an integer. We'll clear that off first. Then we'll increment that. I think you have to set that after doing that. I can never remember. Okay, so that tells us how many planets there are. Now, obviously, there's an extra 1 on that because of the star. So, what we can do then, now that we know how many planets there are, when it comes to drawing each of the planets, we know how many to arrange around the outskirts of the system. I'm just thinking we kind of need it 2 layers deep, because we've got the central star, then we've got the main planets, and then you've got like the scattered disk of Kuiper Belt style objects, and they're not technically planets, they're TNOs, so they need to be represented separately. So I think if we have a big ball in the middle for the star, and then scaled balls for the main planets, the actual planets that are classed as planets, and then another ring for all the TNOs, which means we need to separate out those as well, which means we also need a flag. And that means on here we need to again go over all of this once it's working and polish up how all this is, because we're relying on a lot of just arbitrary booleans here and there to flag certain data points, and it would be better if they were part of the structure more formally. So by doing that, then when it comes to actually generating the system, when we build our list of scattered disk objects, then what we can do is just flag it as a TNO. Then we know that that's one of the scattered disk bodies rather than one of the actual planets within the system. Now we don't have that as a data point for our custom planets. So like the Sol system is a custom system, so we pull all of the data out from our SQLite database, but we don't have whether it's a TNO in there as one of the data points, so we need to add that. I don't think we're defining scattered disk. No, we're not. So yeah, so we need to add that to Earth. Earth won't render properly, or the Sol system rather won't render properly until that's done. For now it will just treat Pluto as a planet. Fairly straightforward actually, Delta, because all we need to do is just record the location of the ship every time it adds a new whole light year. So yeah, we could quite easily draw that on the map. I think. Just trying to think, because the galaxy has a resolution of one whole light year. As you're flying like diagonally through cubes, then the location of the point that we save is going to be in the middle of each cube. So your straight line from A to B is gonna zigzag like this because it's going cube, 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 cube. Now if you zoom out a long way you won't be able to see the zigzag, but zooming in you actually see the zigzag of all the different grid. You're seeing the grid resolution of the galaxy. So we could probably do like a smoothing function on that to remove some of the zigzag, maybe even it out a little bit. But yeah, it's merely a case of just saving every new whole light year to a database and just storing that and saving it to disk. And then when you bring that up on the Holo-Display, it literally just goes through that list of basically just a list of vectors, and it will just draw a line following that list of vectors. Every one whole light year might be too much data, so it might have to be every time you disengage the FTL, then it will draw a data point, because then you'll get nice smooth straight lines then. Yeah, that's probably the better way of doing it. So every time you stop the ship, then you get your data point added. yeah, what Kaji says is true. So the galactic plane is the tabletop that everything's based on. So positive on the z-axis is away from the galactic plane. Okay, so now that we've added that, I guess we need a list of those as well. So we'll zero these out. Yeah, so we'll count the TNOs separately from planets. Moons will handle differently, so that at least gives us a count of each one. I suppose rather than doing this, because we know that the first object in the loop is always going to be the star. So I guess the easier way to do that is, if that is 0, then we're dealing with a star. If it's not, then we need to know, is it one of the TNOs? If it is, then we'll draw the second ring. If it isn't, we'll do the first ring. So let's just draw these a minute. Ooh, actually, I can see where this is going to cause us some grief. Right, so now we won't do this. What we'll do is we'll make 3 separate arrays. Yeah. Right, so the first thing we want to do is just save a reference for the star. That. And then for every other object, so if it's a moon, then we want moons. If it's a planet, takes a minute. And yeah, of course, we need to make these arrays. I might do something like this on the actual Ori map as well, just to make the data structure a little bit more robust, a little bit more sensible. Okay, so add our moons there. Collapse this down in a sec to its own thing. We also want to clear all these again, just to make sure that we are dealing with a clean slate. Create object arrays. Okay, so we do our combined master array, which is this one. And then we go through that, and then we break out that one. I suppose it would make sense to tidy some of that up. We clear the three arrays, copy a reference to the star, build a list of moons, and then build a list of TNOs and planets. Might need to drive this directly from there. We might handle the moons separately, but these two at least need to be separate arrays. So now that we've got that set, what we can do is we can work through each of those in turn. So the first thing we need to do is spawn our local star. And we've got all the details for that there. things like our physical characteristics. Yeah, so that gives us all of that, so we can combine all of that into that and just call that draw star. Okay. And then we can work on the scaling separately. So basically we want to work out our scale so that so the biggest star that we have fits within the scale of the system, and I guess we might need to not render the star its true scale, because I think that's probably going to make all the system objects themselves too small, especially if we're dealing with really big, bright, hot new stars. They're going to be so big that the planets will be tiny on the display, which is no good. So yeah, we'll probably scale the planets based on Jupiter being the biggest object, because as far as I'm aware, Jupiter is actually pretty much at the upper bounds of how big a planet can get. Because the more mass you add, the smaller they get. Okay. Yeah, exactly. Yeah, once we add hypergiants and things, it's going to be a bit of a nightmare. Right, so drawing the central star, so the next thing we need to do is for each on the planets, so we need the length of that array, because we are going to position them outside of the radius of the star in a circle, but we need to spread them out evenly. So we'll take the number of planets and divide a circle by that. So if we take that, convert that to float. Yeah, so we'll divide a circle by the number of things there, and when we do our add static mesh, the rotation is going to be that multiplied by that. Yeah, so that needs to be a float, and the output needs to be a float. And then we're only rotating it on the z-axis. Okay, so yeah, so each one is another step in a circle based on the number of planets. That should give us an even spacing all the way around. And the location of each one is simply going to be if we do get look at get forward vector. Yeah, so get forward vector, and then we will multiply that. Actually, no, we will add if we say 150 to that. And that should place each planet 1.5 meters away from the middle. And if we do the scale as 0.5, then what we should have there is a ring of half-meter balls around a central larger ball. Okay, let's add that to here. And I think we've got can we add that to there? Yes, no, we can't. Yeah, there we go. Because these will get deleted when we reset the Holo-Display. So we just want to make sure that every static mesh component we add, we actually track that we're adding it, so that they don't pile up every time we refresh the display. Right. So, having done that, we need to make sure we have an actual Holo-Display mode that can actually display this. So on medium range, I think what we'll do is we'll add I guess another button on there, so yeah, I think we'll just add it alongside that one. And if we call that toggle overview, toggle system overview. Why is the middle not in the middle? Just pop it there for now. Oh, YouTube crashed. Yeah, my PC doesn't like working with this blueprint. It's by far the biggest blueprint in the game, and yeah, it's not happy with it at all. I think what I'll do on here is I'll just do a more of a fire and forget than tracking this in the sensor's data as such. That said, do we have a reference to the Holo-Display? No. So we're just using this as our payload. So essentially we need to add a data point on here. Yeah, okay. So medium show overview. Just saw that as a Boolean. I'll add that next to the temperature regions because that's what the Holo-Display is reading from. Okay, and then when we do our Holo-Display update, so sensors data gets updated, we do this. So we go through and work out which range we're dealing with, and then it will draw the relevant map. So we need to decide whether or not we're drawing the orrery map or whether we're drawing the system overview. So if we were to grab, where is it? That system overview. Essentially, we just need to do a break on this branch, rather. So if show system overview is false, then we will do what we always do. Otherwise, we will indeed show system overview, and we want a copy of that. Don't think we need our location knowledge. It's more, what are we working with? Sector location. So that one. That's the important one. so that will just render that if show overview is true. So on here, if we just duplicate that a minute. We're just going to literally toggle it. Like that. So every time we press the button, it will essentially toggle this value and refresh the Holo-Display. Let's see whether it works. Okay, moment of truth. So medium range shows you the orrery, and this should show balls. Aha, balls. Okay, so we should have one ball for each planet. Obviously the star in the middle. So we'll move those down to floor level. It's still drawing the orrery map, so to get rid of that. But yeah, that at least toggles that. Okay. Halfway there. So we should, oh, I see. I see, we're hiding that behind a branch. Now we always want to reset it on this one. That'll stop the orrery map showing up. Yes, there should always be a full refresh, so that's fine. Right. Okay, so let's move that down then. If we say -100. And then on these, so X and Y and Z would be minus, say, 150, because we want the star to be kind of above them. Okay, and then scale-wise, we essentially want to scale them based on planet radius. So need physical characteristics, don't we? Just remembered how I did it last time now, actually. So, oh no, I'm losing it. It's going from my brain. So this is in kilometers. So for every 1 kilometer, we want a centimeter. Hang on, there are more zeros than that. Off to the website I use every day. So 1 kilometer is that many centimeters. Did I get it right? No, I didn't. Okay. So we take our body radius and we multiply it by that. I think. I always get this wrong. Yeah, because we're doing a unit conversion. So we've got the radius of the planet in kilometers needs to be the radius of the ball in centimeters. No, not even that. I guess we need to work backwards from Jupiter. So yeah, because what we're doing here math-wise is we need to define how big we want Jupiter to be. So if we say Jupiter is 50 centimeters, so our biggest planet is going to be 50 centimeters, then we need to use that as our scale and obviously work backwards. So if 1 divided by Jupiter, hang on, I think I've got it. Jupiter radius 69 71492. Let's go with that. 71492. Right, okay. I think so, yeah, but the way we need to do it is if we scale that down using Jupiter as our reference, then I suppose no, it needs to be that divided by that, doesn't it? Because Jupiter needs to result in 1. Okay, and then we do right, and then that times our unit that we're using. So because we're turning it into a fraction, so assuming this was Jupiter, then Jupiter's radius divided by itself would be 1, So then we want 1 times 0.5, because that is then half a meter's scale on the mesh. That's it. So then anything bigger than Jupiter would be bigger than 50 centimeters, and anything smaller than Jupiter obviously gets scaled down accordingly. But there's very few planets bigger than Jupiter, so we shouldn't have too much of an upper bounds. Let's just give that a try a minute, see how it looks. Oh, I put them the wrong way. Okay, but yeah, you can see there. So you've got Jupiter, Saturn, and Uranus and Neptune. They are all the right size. And then you've got teeny tiny little balls for the other planets. Okay, that works though. Maybe we'll scale that up a bit so Jupiter's bigger, although saying that two Jupiters next to each other will overlap. Right, let's get them out the ceiling a minute. Oh yeah, so it should have been minus 150. Although we'll do minus 100. No, let's try 150. And we'll turn off the background sphere. I don't know, Anasi, because from what I was reading, they might be more massive, but they're not necessarily larger. Because the way gas giants work, the more and more mass you add, the smaller they get, because obviously gravity increases, so they start contracting. So they grow and grow and grow, but then they start getting smaller, because there's this cutoff point where the amount of mass creates enough gravity to start shrinking them. So there is a cutoff point that defines how big a gas giant can get, depending on how much mass it has. So the cutoff point basically needs to be whatever that radius is. Yeah, I'm not sure you could get a puffy one Jupiter-sized. No. Okay, so Mercury, Venus, Earth, Mars, that would be Ceres. That's interesting actually, because they're in the wrong order. Why are they in the wrong order? But this is a nice way of doing it, because it means you can see an overview of the current star system literally right there in front of you. So you can see the scale of each object relative to each other. Let's go and have a look at that Alpha Centauri system a minute. Pick a planet, any planet. Okay, so in contrast to the Sol system, Alpha Centauri's got some quite big gas giants. Smaller than Jupiter, but more numerous. That's interesting. I wonder what the mass of that one would be. Because for it to be bigger than a brown dwarf, surely it would have to have more mass than a brown dwarf. In which case, why isn't it a brown dwarf? Because it would have surely collapsed under its own weight. I like this. I like this approach, actually. I think doing them in a circle, I think, is good. I think the TNOs, like Pluto, are going to be like so small you can't see them. But I can't think of a better way of doing it without making them so big that they overlap one another. I would have thought anything. I mean, it's very rare that you'll find a gas giant that isn't predominantly made of hydrogen. So it's, you know, it's going to fuse. I think it's more like 12 times the mass of Jupiter. I don't think it's 3. But it's yeah, it's whatever. It's whatever that mass is that it kind of breaches that point where it will start to fuse because of internal pressures. I'll have to look into it. Okay, so let's just check out one more system and then we'll have a look at texturing them. I think the issue that we're going to have with texturing them is running into VRAM issues. We might need to give them generic textures for the class that they are, as opposed to their actual textures. But we'll see. We'll see what kind of impact that has. I predict that's just going to chew up VRAM. Out of interest, let's scale the star based on Sol. So let's say if we wanted Sol to be that big. Although I suppose, no, we can scale that based on Jupiter as well, can't we? Because if we scale everything based on Jupiter, then that means the star scale is actually accurate. This is probably going to be hilariously big, but we'll see. Yeah, it's hilariously big. Wow, how big is that? It's definitely not that big. it's made it tiny. What? Oh, I know why. That's because the radius that's stored for stars is a fraction of Sol, as opposed to the actual radius. I do need to change that at some point. So this body radius here needs to be multiplied by 636,900, I think it is. Hang on, let's just Google it a minute. Radius of Sol. No, not the entire system, just the star. It depends where you look. Oh, 696,340. Yeah, that's what I've got it down as in the game, so I'll use the game reference. Right, so we turn the fraction into kilometers, then divide those kilometers with Jupiter, which gives us our fraction for the scale, and then we want to use, no, I want to stick with the 0.5 so that our scaling is the same consistently with Jupiter. So that means that the scale of the Sun should be accurate to the scale of Jupiter. Yeah, given that I'm stuck inside something, I think that is about right. Yeah, still stuck under it. Yes, so clearly stars are huge. If we just make sure that collisions are off on these, because it should be no collision. And the same with these guys, should be no collision. In fact, more so than that. We don't want them used as occluders. We don't want them affecting the nav mesh. It's just wasting runtime unnecessarily. Right, let's see how hilariously big the Sun is. Oops. Wrong button. It's not that big. I mean, it's definitely drawn it huge. Oh, it's not that big. Can't be that big. So that's the radius there. So R2 would be that. Our Jupiter fraction is that. That'll do actually. Just see what values we're actually getting for those things. That's not right. 2,439. Huh? And why is it doing it over and over? Getting some weird values, so I just need to make sure that we're getting the right one in the data, because otherwise that's very strange. Okay, so the radius is definitely correct in the data. 696340. Which is what we want to see. Okay, let's have a look at Alpha Centauri a minute. Actually, let's just check star details on there. Radius 729805. Okay. make sure the details are correct on there. Radius 729805. Radius 6762. Okay, something's not right somewhere. So we know the data's right on the UI. Let's actually look at the UI and see precisely where it's getting that from, just so that we're all on the same page. So we want that. So physical characteristics. That one. Okay, so we're getting the body radius directly from the physical characteristics, and that's our fraction, so we are storing it in kilometers, and we're just outputting that directly as kilometers. Yeah, on there. So that's definitely the correct field that we're pulling. So why is that wrong? Oh, I see what I've done. I've hooked up the pin from the planets rather than the star object. Like so. So we don't need that. We can just go ahead and take that value in kilometers and divide it by Jupiter. And we don't need that input pin. I knew it'd be something stupid, and it is usually me. That's more like it. Yeah, so if that's Jupiter there, then that's how big the sun is in comparison. So it's quite chunky. But clearly too big for rendering on the Holo-Display. What we could do though is, because we're not drawing this below the floor, we could actually lower that down so that you've just got like a dome with all the planets around it. I mean, that could work. Obviously the distance that you lower the sphere needs to correspond to the radius of the sphere. And of course they would have to scale. So and I guess we can do that from Sol's perspective. Yeah, so if we were to divide that by Sol, that gives us a fraction of 1 for our sun. And then we will multiply that by however far down we want it. So if we do minus 3 meters, I suppose. Then it should scale that with radius and always have the same point showing above the surface, but let's try it and see. That might work. It might not. I might need to take the actual radius of the condensed sphere. Yeah, more than that. Because as the star grows, that dome should flatten out, but still be cut off to the borders of the Holo-Display. Which I really need to make a cylinder rather than the sphere, to be honest. I do need more whiskey, it's true. There we go. So if that scaling were to hold correct, then we should just get a flatter and flatter dome. The bigger the star gets, but it shouldn't get any higher. So if we try a big system like Sirius and see whether or not that actually holds true. It would be much easier just to make a sphere in SketchUp with an origin point at the top, and then I can just scale it with the upper origin, but let's do it with math instead. Okay, so medium range. Okay, so yeah, it's moved it too far down. That's interesting though. We've got a little planet between some gas giants. Okay, so the math for this then. I suppose what we could do, leave it in the middle. And then we can get object bounds. Get bounds. Yeah, this one. So hopefully this scales with that. So that gives us the mesh radius. And then all we need to do is set relative location. So it would be that minus 400. Yeah. No. So we know what our radius is. So it's minus 400. Hang on. No, that minus itself no, because that's just going to be 0, isn't it? So it's going to be that, actually no, that multiplied by minus 1. So that's the negative of that value. So we're moving it down by its radius. Right, then minus 400. Yeah, that'll be it, because we're moving it down by its radius, and that puts its radius in the middle, and then a further 400 down. Yeah, that. So our sun should be in the same place as it was before. Well, that didn't work, did it? Did it make it huge, or did it just put it down here? Oh, now it's down there. It's under the floor. Okay, actually, if we skip that bit, that should put it at the very least in the so the top of the sun should be in the middle of the display, because it's setting the relative location. Yeah, so that's right. So the middle of the display is the top of the sun. So we're only having to move it down then by maybe 2.5 meters. Actually, no, the radius of the display is 2. So if we say 150, we'll get there. We will get there. Well, the idea with doing this is that we are showing the curvature of the star versus the size of the planets. So again, the larger the star, the more this dome will flatten out. So you're able to get a much clearer perspective visually on how big the star is versus the planets. So that's genuinely the curvature of the Sun versus Jupiter, for example, or Earth, right there. That's how big Earth is compared to the Sun. Teeny tiny. So if we go to Sirius now, then we should see a much more flattened out dome because it's a much bigger object. Yeah, I shall go find one. Okay, so medium range. Yeah, there you go. So Sirius, by comparison, we've now got a much flatter dome, which shows you just how much bigger it is versus the size of its planets. It's kind of crazy how massive that is. We could equally do it up in the ceiling rather than on the floor, but once we make it textured like a star, it should look quite cool having the planets above it. And then we can raise the planets up a bit as well, so they're more visually viewable. Now this is a different system now. I'm not sure we've got any O classes in range. We would need to find an open cluster. I know there's one nearby, but I can never remember where exactly. Oops, going the wrong way. What I'm doing is I'm just browsing through different sectors until I find an open cluster, but there's no guarantee that we will get one. Ah, there we go, found one. Open cluster. So if we now go to the long range and switch our focus to that particular sector of space, then we should have some O-class stars available to us. There's one. Okay, we're too far. Wow, that's a hell of a lava line. Oxygen just has to do its regen. There we go. Okay. One O-class star. Yeah, so that's just a carpet of star. Busy system. It's interesting, it's not actually showing the moons on here. Definitely has a bunch. Okay, so this system is predominantly just gas giants and one little rocky planet. Big gas giants at that, actually. I think that one looks visually to be bigger than Jupiter. Yeah, this mouse is getting a bit old and rattly now. That's interesting. Oh, no, of course. So, yeah, of course it's not scanning the moons yet. One of these gas giants was quite big. Okay, and then you got all the icy bodies, which won't be on there. So, all right. But yeah. Now obviously we'll cut off the rendering with the edge of the Holo-Display via the material, so that's easy enough. We could potentially just make the planets a little bit further away as well, just to give them a bit more room to breathe. And if we do that, we can make them slightly bigger. So if we... yeah, I think that's fine as it is. So if we were to do maybe 125 instead of 150, and then we'll push them out maybe 170, and then scale them up ever so slightly, which means that this would also have to be scaled up the same, as we're scaling the whole system at that point. Let's just see if that fits. Yeah, the holo projectors are all these things up in the ceiling. So basically, they're able to project a cylinder, like where the center of the bridge is. So technically, it's a cylindrical display. But we render most things as a circle, a sphere rather. Didn't want to do that. Okay, yeah, so they're a bit further away and a bit bigger. not sure what all these little objects are. Oh, right. No, of course. So on the Sol system, it's including all the TNOs as tiny objects, because we're not flagging them as TNOs in the data, which is why the main planets aren't doing a full orbit of the display. That's fine. That makes sense. Yeah. So it genuinely then does go Mercury, Venus, Earth, Mars, Ceres, Jupiter, Saturn, Uranus, and Neptune. And then that would mean that that one is Pluto right there. So Pluto is teeny. Okay, well, given that Mercury is like small enough to render Jupiter, but also big enough to see, I think that's fine. And these are all real scales, so the scale of the star is genuinely the right scale to Jupiter. So I think, yeah, I think that will do. And I might just squidge those out just a little bit further, maybe. I suppose it would be nice to be able to click on these as well. So as part of the Holo-Display, if you can just click on one of these objects and make it a target, that would be helpful. Right, let's just check. Actually, no, let's just make them bigger, and then we'll give them some generic materials a sec. Yeah, justice for Pluto. I suppose we need lower resolution materials for them, but they also need to be Holo-Display materials. So I guess we would need in the data to have those textures saved, or at least a soft reference to those textures saved in the data that we generate here. So so when we generate custom systems like the Sol system, we've got predefined textures that we can pull upon to render that display. For procedural ones, we can just make a generic texture, but I think that works for those. Yes. I was like in disagreement with declassifying Pluto as a planet, but if you look at it from a technical perspective, it's really not, because there are trans-Neptunian objects that are bigger than Pluto, and they share the same orbit, roughly. You know, they're in the same region of space. So, you know, Pluto's not even the biggest thing out there. So, yeah, it's not a planet. It is a scattered disk object, but I would be happy to accept Pluto as an honorary planet before, you know, we discovered what TNOs were. Right, so I've just noticed the time, so I'll do one more little adjustment and then we shall call it a night. Right, so we don't need that anymore. That's all working as intended. That's working as intended, so we just want to move move these out a little bit. So maybe we'll go 180 and maybe move them up just a little bit more. Oops. Above the star. And then maybe just tweak the star up a little bit as well. That's better. They're more kind of a decent level looking at them. And then what we'll do is when something is targeted on here, so say you target Earth, we can have like a little blue arrow above it just to indicate that it's been targeted. If it's the nav target, similar thing, we'll have like a different symbol above it. And then we'll have some labels above them as well. Yeah. But for now, I shall leave it there. I think we are... What save are we actually? Yeah, I think we're in a good place for a build. I will make sure that that's not breaking anything. And then yeah, we can go ahead and package that up and put it out. I think the moons are definitely rendering a lot more reliably than they were. So you should find a much more sensible mix of moons now that aren't all on top of each other. And yeah, and really now it's just bug fixing and new tutorial. So I need to do a tutorial for the new radial menu and the new NPC commands, get the bugs fixed, and then this thing can go out on a public build, which will be lovely. Okay, so I shall wish you all adieu, and I shall see you on Wednesday for Wednesday stream. So have a great week ahead, and bye for now.